Okay, Assalamu alaikum and good afternoon. Today we will talk about software evolution. And software evolution, or the topics we cover at software evolution is the evolution processes and the program evolution dynamics, software maintenance and how we relate evolution to maintenance, and how do we manage legacy systems. So in general, software change is inevitable, means it happens, definitely it happens, even though it is not really wanted. And this is because new requirements emerge when the software is used, business environment changes, and business requirements changes as well. Errors appear and they must be repaired in any system. New computers or new equipments are added to the system to extend its capabilities, and these computers and equipments has to be included. And then the performance or reliability of the system may have to be improved depending on multiple factors such as the environment or even the services quality. So a key problem for all organizations is implementing and managing change to their existing software systems, as they have already invested money and time in these systems and they want to maintain it. And that's the importance of evolution. Organizations have huge investment in their software systems, and they are critical business assets to them, and maintaining them is just as valuable as keeping those systems. Maintain the value of these assets to the businesses by updating them. And then the majority of software budget in large companies goes to changing and evolving existing softwares rather than developing new softwares. So these are the basic factors of importance of the evolution. Now take a look at this diagram. It shows a spiral model of development and evolution. See, any software starts with the specification, and that applies for spiral model development. Starts with its specification, implementation, validation, and then operation. And once we reach the operation, a new release is delivered. Any iteration would result into new release. As you can see, for every iteration we have a new release, and the development in spiral model is incremental again, because we build over what we have built in the previous release. And this diagram illustrates the lifetime of a software. So the software has its initial development and it is in production. Then it lives some time in the evolution, means we could continue produce or developing functionalities or repairing errors and problems. And then it would live some time in servicing, means we just maintain the system, we don't add functionalities, but we just let it adapt to the business environment and we just use it. And then once the system is no more useful or does not have much of a business value, it would go through a phase out process. So the difference between evolution and servicing, or the three processes that we have seen earlier, is evolution is the software lives in operation or operational environment, and it's in production, and new requirements are proposed and implemented in the system. So we say the system is evolving or in the evolution stage. At the surfacing stage, the software remains useful, but only changes made are those required to keep it operational, such as bug fixes or and changes to related to software environment. But no new functionalities is added. Phase out is the software may still be used, but no further changes are made, and this means the system is being replaced at this time, or we have a plan to move to a different system in a certain period of time. Evolution has several several processes, which depends on type of the software being maintained and the purpose of that software, the development process used to develop the software, and skills and experience of people who are involved. So proposals of change are the driver for the system evolution. Normally comes from different or various departments from the business or from customers. It should be linked with components that are affected by the change, such as allowing cost and impact of the change to be estimated. And change is identified, and evolution continues through the system lifetime. So, from the new system, we have this diagram illustrates the change identification and evolution process. So we have change identification process, change proposal, and then software evolution process, and finally we have the new system delivered. This diagram shows the software evolution processes. So from the change request, we have something we call impact analysis. And an impact analysis is trying to understand the impact of this change on the system and whether it is valuable to the business or not. Then release planning. So if the impact analysis was positive, we plan the next release of the system. Then we implement the changes required, and at the end we get the system release. Now in release planning, we have subcomponents: the fault repair, platform adaptation, and system enhancements. And those are the three categories of processes that we could do in evolution or in system evolution. In change implementation, this diagram illustrates that for proposed changes, we go through requirements analysis, and then we update requirements, and then we update the system through system development. So the change implementation goes through iterations of the development process, and these iterations produces revisions of the system. And the critical difference is that the first stage of change implementation may involve program understanding. Means if means in the development earlier in the diagram, let me get you back to there. At the first stage here was going through specification, but in evolution, or the first time we want to evolve the system, we might need to add something here that we call system understanding or program understanding. And that is especially because the original system developers may not be the same or may not be responsible for the change implementation. So the new team needs to understand the program before they take over and maintain the evolution. And during the understanding phase, the evolution team needs to understand how the program is structured and how it delivers functionalities and what is the proposed change or how the proposed change might affect the program. So that is the responsibility of the program understanding phase. Now, not all the changes required are always or not all changes can wait, if you could say. So there are certain changes that are urgent, and urgent changes may fall under one of those categories if there is a serious system fault that has to be repaired to allow normal operation to continue. So this is an urgent change request that cannot wait to go through the normal change process. If changes to the system environments caused unexpected effects, for example, if the server operating system upgrade has shown certain anomalies in the system or on system processes, so this has to be handled urgently. Or if there is business changes that require very rapid response, otherwise the business would be affected heavily, so this also is considered as urgent change request. And this diagram shows how emergency or urgent repair process goes. The change request is filed, then analyzing source code starts, then modification of source code, and delivery of modified system. Agile methods are related to evolution, and actually they are more fit to evolution compared to normal or plan-driven models, as agile methods are based on incremental development. So transition from development to evolution is seamless, and automated regression testing is quite valuable because it is designed to evaluate changes made by through phases, and changes may express as additional user stories, and we have seen this in testing. Now, handover problems, as we said, the development team might not be the same when it comes to evolution of the software. So organizations may have development team for development and evolution team for to handle the upgrades and evolution of the system. So if the development team are using agile approach and evolution team are using plan-driven approach, we have a handover problem because the evolution team expect detailed documentation, which is not produced in the agile processes. And the other scenario is where development team is using plan-based approach, and the evolution team prefers agile method. Now, the evolution team may have to start from scratch developing automated tests, and the code in the system may not have been refactored and simplified as it is expected in agile development. So those two scenarios are called handover problems. Okay, Program evolution dynamics, we will start this in the next